Greetings, my electronics enthusiast friends. Welcome back to a new episode of Cool Electronics Guy, where the electronics are cool, and that's all I have to say about that. Happy Memorial Day. If you're looking for a great craft beer to enjoy on your holiday weekend, then check out our beer of the day. Today's beer of the day is called Bath Bomb. It's made by Fifth Frame Brewing Company out of Rochester, New York, not too far away from where I am. This is a heavily fruited sour with cherry, lime, and coconut. It weighs in at 6% alcohol by volume. And this is a new brewery for me, so I never had any of these beers before. As soon as I took the first sip, my mouth just erupted with flavor. If you like coconut, like me, I love coconut, you're going to love this gem of a beer. It's very sweet, but not sickly sweet. It's bursting with coconut flavor. Cherry and lime aren't as strong as the coconut, but they're very well balanced and definitely at different levels of delicious goodness. I honestly would add this to the ranks of my top 5 favorite beers. Beer Advocate rates this at 3.5 out of 5, but Cool Electronics Guy gives it a 9.5 out of 10. You be the judge and leave your comments below. Remember though, as you sit back at your barbecues this weekend and enjoy a cold one, don't forget to remember our United States military personnel who've died while serving our country. That's what the holiday is all about, guys. Now let's get started with today's project. This is the 10th project in the Arduino Starter Kit. It's called Zoetrope. This may be the toughest project yet. Arduino rates the difficulty as 5 out of 5. They say it takes about 30 minutes to complete and builds on projects 1, 2, 3, 4, and 9, which was our last project. The main goal of this project is to create a moving image in forward and reverse when connecting a motor to an integrated circuit with some still images. You're probably asking yourself, what the heck is a zoetrope? It's a device that creates the illusion of motion from a bunch of still images that have small changes in them. It's kind of similar to the concept of a flip book, but this is more a complex version. The zoetrope that we're going to build will animate a cartoon LED, which you'll see. We're going to make it move with our motor. We're going to add a switch to control direction and to turn it on and off, and a potentiometer, people call them a pot, for speed control, so we can adjust the speed. On the last project we used an electric motor that turned in one direction. If we physically flip the power and ground wires on the motor, then it would turn in the opposite direction. To actually do this takes time, and it's just really a pain. So we need a component that will allow us to do this quickly and efficiently. And this component is called an H-bridge. They use the letter H because the circuit it's in the shape of, you guessed it, an H. What a surprise. But very simply put, it's just an electronic circuit that switches the polarity of voltage applied to a load. It allows DC motors to run backwards and forwards. The H-bridge that we're using today is in the form of an integrated circuit. If you're not sure what an integrated circuit is, it's a set of electronic circuits on a small flat piece of semiconductor material, usually silicon. A large number of transistors are integrated into a very small chip. An integrated circuit is usually abbreviated IC. It has a notch on one end, which is considered the top, and there are pins that run down both sides. Some integrated circuits have more pins than others and have different functions. The top left pin is number 1. The next down is number 2, and so on, all the way to the bottom. Then if you make a visual U at the bottom, the next consecutive number pin will be the one on the bottom right, and increases in consecutive values until you reach the top. Ours is pins 1 through 8 from top left to bottom left, then 9 through 16 from the bottom right to the top right. It's pretty simple, right? The components that we're going to use in this project today are 1. H-bridge integrated circuit, 2. 10K ohm resistors, 1. electric motor, the same exact one that we used in the last project, 1 9-volt battery, and I actually bought some since I had to use the one in my multimeter for the last project. We're going to use 2 tact switches, 1 potentiometer, 1 9-volt battery strap, and lots of jumper wires as always. Alright, now we're going to work on wiring it up. As you can see, we've already started. We're going to walk through this step by step. Can you guess what the first step is going to be for our wire up? If you said connect power to 5 volts and connect ground, then you're right. Same as all the other projects. Next we'll add our 2 switches. You can see we have them on there. One side of each to power. Be sure to add a 10K ohm pull down resistor in series with ground on the output pin of both switches. The switch on pin 4 will control direction, and the switch on pin 5 turns the motor on and off. Connect the potentiometer to the breadboard. We're going to wire 5 volts to one side and ground to the other. Attach the center pin, it's called the wiper, to analog pin 0 to control the motor speed. And then we're going to straddle the H bridge across the center of the breadboard. Pin 1 goes to digital pin 9. This is the enable pin in our integrated circuit. 5 volts will turn the motor on and 0 volts will shut it off. This pin will pulse width modulate the H bridge and adjust the motor speed. After that, we're going to connect pin 2 on our integrated circuit to digital pin 3. Connect pin 7 to digital pin 2. These pins will be used to communicate with the H bridge so it knows which direction to spin. For example, if pin 3 is low and pin 2 is high, the motor will spin in one direction. If 2 is low and 3 is high, it'll spin the other way. And if both pins are high or low at the same time, the motor will stop. It's just pretty simple stuff. Pin 16 on the H bridge is for power. We're going to connect that to 5 volts, and pin 4 and 5 go to ground. Our motor connects to pin 3 and 6 on the H bridge, and will switch on and off depending on the signal you send to pins 2 and 7. We're going to plug the 9-volt battery strap without the battery in it to the motherboard power rails. Make sure the battery's not in it when we do it. The Arduino ground should get connected to the battery's ground. Connect pin 8 on the H bridge to battery power. This pin powers the motor. And please make sure you do not have your 9-volt and 5-volt power lines connected. They should be separate. Only ground should be connected between the two. And once we get this wired up, then we'll show you what it looks like, and we're going to move on to the programming. And as you can see, there's the final wired up project. If you want to look carefully at that and compare it to your own. We're going to go ahead now and start the programming for this. There's a lot more programming on this one than the previous number 9 project. So as soon as we get this programming done, we're going to move on to actually building the physical zeotrope. Alright, well, we've got all the code finished, and we've got the actual device built. The actual physical parts of the Zoetype are the pinwheel, as you can see, that we used in our last project. That's the base, and then the CD that we use is still in there. There's a black cardboard cutout with slits and tabs on it that rolls into a cylinder, as you can see there, and attaches to the pinwheel. There's little tabs that slide into it. Then there's this white strip of cardboard with our animation on it. It attaches inside the black cylinder. Can you see that? It's this whole thing is really not the greatest thing. Nothing really seemed to fit well. The black cardboard tube, you can't really make it round. There's not enough tabs on there to connect it. And then the inside white piece, you got to kind of see how I've got it bent to fit in there. That's the best you can do. It's because it's supposed to go on the inside, and it's way bigger than the black part. Now we tested the project. We know that everything works. We did that before we attached the motor. You can see on the bottom how the motor attaches just like the last project. We plugged the R3 into the computer and attached the battery. And then the motor should spin when we push the on-off switch, which we already tested it without this. So we know that the motor works. And now we're going to show you guys how it works. Go ahead and I think you have to turn the potentiometer. It should already be on. And see, now this thing goes pretty quick. I noticed on the slower settings, it seemed like I could see it a little bit better. I mean, it's really a great project that teaches you how to use the motor in different ways. The programming was pretty cool. It taught us a lot of stuff, but the actual physical components of the zoetrope really aren't great. I'm kind of disappointed in that part of it, but like I said, the rest of the project was pretty fun. Now you can go ahead and customize your own project. Try creating your own animations or adding LED lights so you can get a dramatic lighting effect while using a low lighting situation. Just have fun with it. So that wraps up project number 10. I don't think it was too difficult. It just fell off the motor. It was definitely a great learning experience though. Our next project is number 11, and it's called Crystal Ball. It's another level 5 project, and it involves using an LCD screen, so that's going to be cool. It's going to be lots of fun, so be sure to subscribe to our channel and ring the bell so you don't miss out on any cool electronics projects. As always, please leave your comments below. We'd love to hear from you. Have a nice Memorial Day weekend, and as always, drink some great beers and make some cool electronics. See you guys next time. Have a good one.